Welcome to the Rich Report, a podcast with news and information on high-performance computing. Today, my guests are from Adaptive Computing. We have Brady Kimball and Ken Nelson. So welcome to the show, guys.
Hey, thanks for having us.
Yeah, it's a pleasure.
Well, terrific. We tried to hook up at SC11 in Seattle, but now we're recording this so we can get people caught up on what Adaptive is doing. So, Brady, I brought your slides up. Why don't we start with that?
Okay, great. Thank you very much. So what I'm going to go ahead and talk about is really one of our offerings that we're offering this next year, which is our Moab HPC Suite Enterprise Edition. And I'll also be talking about a number of just high-level themes that we are slated in tackling this next year. Ken's going to be spending some time doing more of a deep dive around Torque 4.0, which is one of the more significant HPC announcements that we had this last year at supercomputing. So really what I wanted to highlight with the Enterprise Edition on that slide is really it's taking our Moab's battle-tested acceleration, uptime, automation, SLA enforcement, and HPC management, and really building and fleshing those out. So really we've been focusing on scalability, being able to push more and more jobs through the system, being able to manage more and more nodes, and still keeping all that high resource utilization that adaptive computing is known for. On top of that, being able to respond to automation through automated fashions, failures that we have in the system, whether that's job failures, whether that's hardware failures, being able to make sure that we're making those deadlines. On top of that, we're looking to actually continue to flesh out the SLA enforcement that we have and be able to adjust the workloads through dynamic flexing of workloads and being able to show those in reports and so on. So really, it's the things that our customers are very familiar with, but as we're with commercial space, making sure that our uptime is always there, making sure that our policies are matching the commercial needs that our customers have, and providing those and justifying the story that our product tells through reports and statistics. So if you want to go to the next slide, really highlighting those themes in the Enterprise Edition, looking what I've already highlighted some of those things in the last slide, is that we're looking at our large-scale readiness. Ken will be talking about the Torque 4.0 piece, but we've already starting with Moab 6.1 in the summer and looking towards our next releases. We'll continue to flesh out the readiness from Moab's perspective. On top of that, we have continued fleshing out of core scheduling and intelligence. So this is topics like SMP and SMT, being able to have more granularity around threads and cores and all the different architectures that are coming out, as well as greater understanding of grid environments around data staging. Storage and big data jobs are a challenge for different organizations right now, and being able to flesh those out. And lastly, wanted to highlight that really Moab in enterprise, commercial, academic spaces is turning more and more into a service. And so what I wanted to highlight real quick was in the next slide, we have basically an architecture diagram of our Moab suite being wrapped around with a Moab web service. So what this allows us to do is it allows us to have access to Moab from a portal, such as our own in-house tool, Moab Viewpoint, which is our administrator and end-user portal to interact with the Moab Workload Manager's piece. But on top of that, it allows us to plug in third-party portals, so if a customer already has a portal, or we've seen in some customers' cases actually wrapping business logic in and tapping into our web service that way. So as it stands right now, we do have a number of APIs that a number of our customers are familiar with, but the web service is really getting to a standard compliant REST API that allows people to access it in a language agnostic way. On top of that, you can see that the web service wraps all the way around to the resource manager layer, and we are known by quite a few of our customers for our flexibility and being able to plug into a number of different data sources. Well, this is taking it to the next level, where we have a asynchronous plug infrastructure that allows us to plug into things like Torque, storage APIs, network hardware APIs, OMDBs, our existing service manager. And what this allows us to do is it allows us to provide a SDK for people to plug in their tools into our system in a much easier way. On top of that, you get a lot of things for free. It allows us to, we talked about the scalability. Well, with scalability, you run the risk of having, failures and things like that. So with this allows us to handle failures by having caching, having greater high availability. So, for example, if we need to take the Moab Workload Manager down for maintenance or some period, you can actually have cached data within the web service, and so customers can still get their data even though Moab is down. So on top of that, the plugin infrastructure allows us to have the plugins have access back into the Moab information, whereas right now it's kind of a one-way street. So really, these are the types of things that we're looking at this next year, and we're really happy to be able to provide these to our customers, and that's all I had.
Well, terrific. So that's the enterprise piece. What do you guys got going in HPC?
So that's, I think Torque is part of it. Of course, Moab is always part of HPC. But one of the things we knew we had to do in order to take advantage of the increased throughput and scalability of Moab is we'd have to have a resource manager that could be able to do the same thing. And so the focus of Torque 4, if we could move on to slide 6, is to overcome Torque's legacy. So Torque is a descendant of PBS, which got its start clear back in 1993 and 94. And as you can see from this list, back then, DOS was still the predominant OS for the PC market. We had, in 1994, Intel released a 100 megahertz Pentium chip. And also we see that Linus Torvald released the first version of the Linux kernel. So the end result is that PBS and Torque were built around a lot of the hardware restrictions and practices of the 90s, and things have really advanced since then. Can we go to the next slide? So there's a lot, like I said, there's a lot of improvements. Hardware is much faster. We have multiple processors on a single chip. The networks are far more reliable. Disk space is faster. We have threads, which didn't exist when Torque was first started. And we wanted to be able to take advantage of all these so that we can bring Torque into the present so that it can better manage the kind of systems that are out there today. These are our goals. Scalability, we want to be able to support tens of thousands of hosts, not just processors. We can already support as many processors really as you can put out there, but hosts become a bigger challenge, and that was one of our goals. Another thing with the higher number of hosts is we have to have improved communications. We need better throughput, and also we need to get better response for users and things like that. And again, we say we improve reliability and security. Security becomes, as we move into cloud, security becomes a bigger issue for Torque than it has been in the past. We'll go ahead and move to the next slide. I was mentioning before, we want to scale to some very large systems, like say tens of thousands of nodes. So far internally, we've been able to replicate a 7,510 host cluster and then just fine that. And we believe that we'll be able to go way beyond that number with the algorithms that we're using. Again, part of that is reducing network overhead and bottlenecks, and I'll talk about these briefly in some other slides. And one of the other big improvements is we have removed UDP as there. So Torque was built with a protocol called RPP, which stood for Reliable Packet Protocol, but it was also written over UDP. And as systems have grown larger, we have jobs now that require millions of bytes of data to be transferred between different hosts, between compute nodes. And UDP, of course, is not reliable and creates a problem. And so we decided that we need to start using TCP, which we have done. So all of Torque 4 is all TCP based. You can go ahead and go to the next slide. And so, again, another thing that we're taking advantage of is the multi-threading capabilities of Linux and Unix systems. And this is improved responsiveness. One of the problems that users would see in the current and previous versions of Torque is when it starts getting busy and full of jobs that sometimes you have to wait for your job to be submitted, or if you do a queue stat, it can take a long time, or worse, somebody else has a queue stat on a full system and everybody else has to wait for that to finish before they can do more work. But with the multi-threaded Torque, that's no longer the case. Everybody gets the system as if the system it feels like it belongs to them, and the throughput goes way up. Another thing that ends up being a side effect of that is that Torque 4 becomes more robust. So if one process or one user request becomes bogged down, it doesn't bog down the rest of the system. All the other users are also able to continue to do the work that they want. And we've done a lot to optimize some internal algorithms to increase the speed. And then we also have added a feature that while in Torque Forward, the security part of it is not fully implemented, the infrastructure for it is there for future versions of Torque, and we'll talk about that in a minute as well. If we could go to the next slide. So a big problem with you have such large systems is how do I keep all of my nodes current on the status of other nodes in the system? And we have two ways that we're addressing that. One of them is with what we call the job radix, and the other one is with the MOM hierarchy, and we'll talk about in a minute. And both of them kind of work on the same principle. The job radix is for launching very large jobs. And what it does is it allows me to, or the user allows the user to say, I want to have a hierarchy of, say, 3. And what that does is it, instead of by default, when a job launches, the mother superior has to talk to every other node in its job. The job radix, what it does, it says, okay, the mother superior will communicate with 3, or whatever the job radix is, and each of those nodes will then communicate with 3 nodes until all the nodes are filled in the job. This vastly reduces the bottlenecks on the network, so you don't have a lot of network traffic coming to a single point in the network. And again, it's all been moved to TCP, so it's much more reliable. Quickly go to the next slide. This is just a quick example. Let's say that I submit a job. QSub is how Torque submits work, and we set a job radix of 3. And so go ahead and go to the next slide. And this is just an example of how the communication would end up being set up. In this particular one, we have 3 levels. The sisters on the bottom level would communicate to the intermediate sisters, who would then communicate all of the information, aggregate it back up to the mom. And if we go to the next slide, so we added a thing called the Torque Authorization daemon, and this is for submitting jobs. One of the things, it replaces an old program called PBS IFF, which had the sticky bit set. So users would this is what was used to authorize users to the server. And because the sticky bit was set, PBS IFF would come up as root. The problem, it has a lot of problems with it, one of which is security. It is not necessarily easy to get around, but it can be gotten around. And the other one is it's just not scalable. And the TorqueOffD is the name of the daemon which replaces it, which is controlled and started as root. So it's controlled by the administrator. So users aren't starting up the executable to do their authorization anymore. And then we're going to be able to add in some type of public-private key authorization so that the server can be more assured that the submission host is who they really are, who they say they are. Finally, the MOM hierarchy, this is for similar in that it's a hierarchy, again, like the job radix, but this is for all of the MOMs as they do their updates to the server. And the idea is that we needed to improve our efficiency. One of the problems on our larger networks is that MOMs tend to drop out for no apparent reason, even though that they're perfectly healthy. And it also, again, reduces the congestion to a single point. Not all of the moms are communicating directly to PDF server. They go through a hierarchy throughout the trees, and it's, again, a more efficient, more reliable way of networking. Okay, so the mom hierarchy is a optional feature in Torque, and the idea is that administrators can populate the mom hierarchy file in a way that matches the network topology of their system. So I can cluster moms who are close to get to each other in the network to do their status updates, and then one of the nodes from all up to each other, and then one of those mom nodes would then update the server with all the information. So this reduces the amount of traffic coming into the server, plus it also localizes the network traffic it localizes the network traffic between the moms instead of, so you don't have traffic going all across the network. Torque 4, if we go to the next slide, we plan to release this in the first quarter of 2012. And if people want to, they can already use Subversion, and they can download Torque 4 right now at the URL that's here on the slide. And we'd appreciate feedback from anybody who's willing to try that for us. And that's all I have. Thanks.
Well, thanks for that, Ken. I guess let's start with the most recent things, so I don't forget my questions. But I understand you had a huge turnout when you were presenting this at SC11. Something like over 100 people came to check this out. Is that correct?
They did. The Torque community actually is a very active community. Even though Torque's been around for over 15 years now, it's proven to be pretty reliable. People like to use it, and they get questions answered. We get a lot of patches submitted from the community, plus a lot of really good ideas also come from the community to keep Torque moving ahead.
Well, good. I was going to ask you about that, getting the community feedback. Do you share with them a roadmap, or do they just feed you a list of things that they want added?
So we do try to keep them updated with our roadmap. We need to sit down and revise a new roadmap. We've got a couple of things that we're going to be putting into the next versions of Torque. But really, a lot of the feedback that we get from the community is what has been going into to Torque, and is things that we put into Torque 4 to meet the demands of users.
Well, terrific. Okay, Brady, I got some questions for you, because there's a lot's been happening in the job scheduling space, as you know. Obviously, there's been some big changes in the landscape, right? One of the big job scheduler software companies is becoming part of a big hardware vendor. Has your phone been ringing from your partners and their partners talking about what you might be able to do in the future?
Obviously with the change in the landscape, obviously, there's various interests from partners and things. So I think we're kind of in the early stages right now where everyone's trying to understand what these moves mean and how it impacts, a business. We have already seen some changes, in different people engaging with us from a partner as well as an evaluator perspective. So, but it's pretty early in the change, so we'll wait and see, I guess.
Yeah. So Brady, coming from your roots in HPC, everything at SC11 seemed to be around big data and data-intensive computing. And it seems like Adaptive has its feet in both worlds, the commercial, the enterprise space, and the HPC space. Does that make the outlook for Adaptive look really bright?
It definitely does. Obviously, we have had a lot of validation in a number of different markets, in scientific computing and commercial, financial services, oil and gas, EDA space. And like you said, it's pretty consistent across the board that as resources get cheaper, really the thing that people are becoming more and more concerned with is data. So we are, like I highlighted in the integration enablement slide, we're looking to build out the storage solutions and the robustness in our APIs, because MOAB's already very flexible, but really we're looking to be able to make it easier to plug into people's storage solutions, whether that's something that a vendor provides from a hardened API, or whether that's a customer. We have a few of these that have homebrew storage solutions, actually some homebrew file systems. So we have seen validation there, and yet we're sitting very pretty there.
Oh, terrific. Well, Brady Kimball and Ken Nelson, I want to thank you both for coming on the show today.
Hey,
thank you very much for having us.
You bet. Okay, folks, that's it for the Rich Report. Stay tuned for more news and information on high-performance computing.